So here's how to get light for free or very, very little to have to pay for. So here is a current limiting box. It's an X factor capacitor reactance reactive. And what this does is it limits the current to 50 milliamps or less coming from the mains line or any source of 60 hertz AC. The frequency is very important for the calculation of the X value of the capacitor. And this gives you a voltage but very low current, which charges this capacitor very quickly here, and it uses an SCR dump method with a neon that triggers at 100 volts and charges these not high voltage but regular voltage capacitors, 12 volt bank here, supercapacitors, and it builds up a charge in here which allows to run a high frequency 12 volt inverter, very efficient, which is right now connected to a lamp just right here, output, and we actually get 15 watts of this. Requires 15 watts to operate, but we're not actually taking 15 watts from the mains line right now. We just found a way to produce the equivalent using some other method here. So it's not tapping into the electric company illegally or bypassing their meters or anything. They can't charge us for what we're not using, right? We're limiting ourselves at 50 milliamps. See, this light here wouldn't be able, requirement 15 watts to be able to run directly off of this. It's not enough. It's highly limited. You could stick your tongue to the outputs of these two wires here and nothing would happen. This is how low we've gone. But it charges the capacitor, and the way the capacitors pulse and have this temporary electret effect and then to another, it does something. And with the efficiency of the high frequency into here, we get the same equivalence out in lumens of that 15 watts without actually having to pay very much. Just 40 milliamps input instead of the regular 15 watts to get the exact same effect. And because of this pulsing going on here, it maintains our charge. So I'm going to show you that right now. So I'm going to just plug the inverter into the capacitor bank, 12 volts. So as you see, very, very bright lamp, full brightness, and if you hear that clicking, that's actually the rate of the capacitor dumping. It slightly affects the frequency of the inverter, and you can actually hear the pulsing. That's the SCR dump. And what it does, see, we're able to maintain the charge on the capacitors. Instead of draining them, they build right back up as it goes. Because of this dumping process here at 100 volts, you're hitting the 100 volts. Every time you hear that, it's 100 volts dumping into this capacitor bank. So of course it's going to do something, right? I mean, and it's not current driven, it's voltage driven, but we're able to convert it to something that, see, this is a very bright. I understand it's only 15 watts of input requirement, but we're getting the full lumen effects here without being plugged in. We're not using this 15 watts from the power plug, you know, and we maintain a charge. It just goes up. Eventually, I would actually have to load it more because these supercapacitors have a certain rating at about 13.5 volts. I'm at the max. I'm actually not loading this enough right now. But I would never be able to do this. I just want to emphasize that this will not run directly off of this 50 milliamp output. Just impossible, cannot do. This pulsing makes it happen. This capacitor dump. And the high frequency efficiency of this inverter. You're going high frequency, you get more clicks. Very bright, it's blinding.